So hello all of you. So let us have a brief introduction to unit number 3, trees. So far we discussed about the data structures where linear ordering was maintained using arrays and linked list. For some problems it is not possible to maintain this linear ordering using linked list. So we go for non-linear data structures such as trees, graphs, etc. to solve more complex relations that can be expressed very easily. So here we concentrate more on the trees, and here we will use doubly linked list for representation of the trees. So in general, a tree is a data structure which is a collection of 0 or more nodes and finite set of directed links called branches. These are used to connect the nodes. So the first node in the tree is called as the root node, and the remaining nodes are partitioned into various subtrees, either as a left subtree or right subtree. In generally, the trees can be divided into two types: general trees and binary trees. Right? Okay. So before we continue, one thing to be noted is the number of branches that are associated with each node are called as degree of the node, whatever the branches that are attached with the nodes. Like for example, if a node is having 2 branches, so the degree of the node is 2, right? So suppose if we go in more depth way, we can see that when a branch is directed towards the node, we say that it has in degree branch. And when the branch is directed away from the node, so we say that it is out degree branch. So let us see about the definition of binary tree. So binary tree, here we can say that in general, the tree in which each node has either 0, 1 or 2 subtrees is called as a binary tree. Either a 0, 1 or 2 subtrees is called as a binary tree. When we look over the node structure, the node structure can be found out into 3 fields, okay, as that of in double-ended queues, linked list. So the middle field is information field, the left field is the left link that gives the address of the left subtree, the right link is a pointer that gives the address of the right subtree. So this is a pictorial representation of the typical node in a binary tree, right? So when I talk about the root, the 3 groups that are present within the binary tree, okay, so first group is called as the root. Here if the tree is not empty, so the first node is always the root node. So next we go for a left subtree. It is a tree which is connected to the left of the root. Since this comes under the root, it is called as the left subtree. Right subtree, it is a tree which is connected to the right of the root. Since this also comes under the root, it is called as right subtree, right? Okay. The following figure shows some of the binary trees. So here you can see, as according to the definition, the binary tree is a tree which is a collection of either 0 or more nodes. Okay, either 0 or more nodes. So either it may have a 0 node, 1 node or 2 node, not more than 2. So figure 10.2 represents various types of binary trees, in which figure 10.2a is an empty tree. Figure 10.2b is having a tree with only 1 node as a root node. Figure 10.2c are having 2 nodes. Figure 10.2d are having 3 nodes. So here check out the another set of figure, wherein figure 10.3 represents 3 more figures, a, b and c. Here you can see that in the figure a, it is not a binary tree because it has more than 2 subtrees. because it is not getting eligible as a definition of the binary tree. Figure 10.2b is not a binary tree because node 100 has subtree 200, node 200 has subtree 300, node 300 has subtree 100, and cycle repeats. There should not be any cycles, so this is not a binary tree. So figure 10.3c, the node 100 has subtree 10 and 10 has a subtree 100. If 10 is a subtree of 100, then 100 cannot be the subtree of 10. So this is not a binary tree, right? Now let us see various terminologies associated with the trees. First one is the root node. The node within degree 0 is called as the root node. It is the first node in the tree. Here, for example, in the figure, we can say that 100 is the root node of the tree. Okay. Second terminology is the child. The nodes which are all reachable from the node X using only one edge are called children of a node X, and the node X is the parent for all those children. Here, when we take an example in the figure 10.4, what we are seeing now, 50 and 60 are the children of the node 100. 50 and 60 at the level 1 or else height 1 are the children of the child nodes of the node 100. Okay. In the same way, 80 and 40 are the children of or the child nodes of 60. 70 is the child of 50. 35 and 30 are the children of the node 80. Next terminology to be discussed is siblings. Two or more nodes having the same parent are called as siblings. As according to the figure, we can say that 50 and 60 are having the same parent 100, so 50 and 60 are siblings. Another thing we can notice that 35 and 30 have the same parent 80, so we can say that 35 and 30 nodes are siblings. In the same way, 80 and 40 have the same parent node 60, so we can say that 80 and 40 are siblings of the node 60, right? Next terminology is ancestors. The node in the path from root to the specified node X are all ancestors of the node X. I would like to repeat, the node in the path from root to the specified node X are all ancestors of node X. Here, for example, when we notice 100 is the ancestor of 50. In the same way, 50 is the ancestor of 70. Like that way, we can say that 80 is the ancestor of 35, and even 100 is the ancestor of the various other nodes like 70, 50, 35, 30, 80, 60 and 40. Okay. Next, descendants. The node in the path below the parent are called descendants. In other words, the nodes that are all reachable from the node X are called descendants of X. Here, as according to the figure, we can say that all the nodes below 100 are descendants of 100, as because every node can be reachable from the root node 100. Next, left descendants. Next one terminology that we need to discuss is left descendants. The node that lie towards the left subtree of the node X are called left descendants. For example, 50 and 70 are the left descendants of 100. 80, 35, 30, 40 and 60 are the right descendants of the node 100. We can also verify in the next terminology about this. So when we speak, 80, 35 and 30 are the left descendants of the node 60. Okay, 35 is the left descendant of the node 80, right? Next one, right descendant. The node that lie towards the right subtree of the node X are called right descendants. As according to the example, we can say 60, 80, 35, 30 and 40 are the right descendants of 100. Right? 30 is the right descendant of the node 80. In the same way, 40 is the right descendant of the node 60. Next terminology to be discussed is the left subtree. All the nodes that are all left descendants of the node X from the left subtree of X are the left subtree. For example, 50 and 70 form a left subtree of the node 100. 80, 35 and 30 form the left subtree of the node 60. Right subtree. All the nodes that are all right descendants of the node x form the right subtree of x. Okay. For example, when we see the figure, 60, 80, 35, 30 and 40 form the right subtree of the node 100. Okay. So in the same way we can say 30 is the right subtree from the node 80, as well as we can also say that 40 is the right subtree of the node 60. Next terminology to be discussed is parent. A node having left subtree or right subtree or both is said to be a parent node for the left subtree as well as the right subtree. The word father can also be used in the place of parent. Okay. For example, when we see the figure, 100 is the parent for 50 and 60. 50 is the parent for 70. 60 is the parent for 80 and 40. 80 is the parent for 35 and 30. Next terminology to be discussed is leaf. A node in the tree that has an out degree of 0 is called a leaf node. In other words, we can say that leaf with an empty left child or an empty right child is also called as a leaf node. It is also called as a terminal node or an external node. As according in the figure 70, 35, 30 and 40, these nodes are called as the leaf nodes. Next is internal nodes. The nodes except the leaf nodes in the trees are called as internal nodes. Example, 100, 50, 60 and 80 are the internal nodes of this figure or of this tree. Next is external nodes. The leaf nodes in the trees are also called as external nodes. For example, same as according to the previous terminology leaf, 70, 35, 30 and 40 are the external nodes in the figure. Next is level. The distance of the node from the root is called as the level of the node. In a tree, the root has the level 0 and level of any other node is one more than that of the level of its root node or a parent node. For example, as in the figure, we have the labels being marked. So every node we get a label to be indicated. Next is height or depth of the tree. The height of the tree is defined as the maximum level of any leaf node in the tree. So whatever the maximum level the leaf is having, that is the height of the tree. Here in the figure we can see that 35 and 30 are the two leaf nodes having the highest value for the height of the tree. So the maximum height of the tree is 3, right? So here we stop with the introduction to trees. In the next video we start with the type of binary trees.